Okay, we can start. We are excited to welcome you all to today's Angels Meetup, a gathering of patient developers.
Okay,
Okay,
we
one
can start.
minute. We're excited to welcome you. So, yes, yes, okay. Hmm. Today, we're honored to have Jason Warner with us, an Angular GDA, dedicated mentor, community meetup organizer, and aspiring writer who has been inspiring developers with his deep knowledge and practical guidance around Angular. Jason will be presenting a highly valuable and relevant topic, structuring code to, to avoid shell socket testing. In this talk, Jason will walk us through how proper code structure not only improves maintainability but also help us to write tests that are reliable, meaningful, and a lot less painful. Whether you are just getting started with the testing or looking to refine your architectural decision, this decision will provide insightful insights you can apply right away in a project. Please join me in giving a warm welcome to Jason Warner. Jason, you can start.
Yeah, thank you. I'm very happy to be here, Ilias. Very, very good introduction. Um, I enjoy the Angular community. You guys are very, very friendly, and I'm excited to speak to NG Asia. I have a lot of good friends in NG Asia, and I'm excited to be speaking with the people here. Um, to get started, let's go on a little bit of a journey. Um, so let me share my screen and get Zoom out of the way. Okay. Um, One thing there is a repository for today's talk. The link, I believe I shared in the chat. Um, it's the GitHub repo for the testing structure workshop. So if you guys wanna follow along or potentially check that out, feel free to clone that repo while we do a little bit of a detour, right? And this detour is something that I've been thinking about for the past couple of years, and it becomes more and more relevant as the job market becomes more difficult based on AI. Uh, our industry has been impacted by AI quite a bit, and how can we as developers differentiate ourselves from AI, right? Um, my my argument is that if we differentiate ourselves on writing code, we've already lost the battle. Um, AI can produce way more code faster and easier than any of us can do it. Um, and so we need to look at our roles as engineers and developers in a different light. And one of the big important things that we can look at is what is the cost of ownership of our code? Um, so if we think about like cars, right? There are a couple of vehicles in the US that are well known for running forever, right? If you buy like a Honda or a Toyota, it's just going to run forever. Um, Very, very low cost of maintenance, very, very low cost, repairs. You can often repair it yourself. They're just really easy to own and maintain cars. If you look at the other high end, you've got cars like there's a famous, if you guys ever want to go fall down a funny YouTube rabbit hole, Go look up dealerships talking about the Lotus Elise. The Lotus Elise is an expensive car to own. Most dealers will tell you that if the car doesn't catch fire during the test drive, that they consider it a win. If the vehicle isn't brought back for repairs within the first month, they consider that a win, right? So if we compare like a Toyota or a Honda vehicle that you can own for, I've had friends whose parents have owned Toyotas for 20, 30 years and they still run. Very, very easy to maintain, right? Versus a Lotus Elise. And the cost, the upfront cost is also very, very high. So when we think about our code, is the code we're writing more like a Honda Civic, easy to maintain, easy to own, or are we writing code that's more high end, likely to catch fire during the demo, likely to need repairs immediately after release, right? Um, and that's where this concept comes in of um, what can we do to make our code more maintainable, um, and more and lower that cost of ownership, right? So let's go on a little bit of a tangent. Um, and when we talk about what makes code cheaper to create, makes code cheaper to maintain, what makes code easier to test, we can talk about something that everybody's pretty familiar with, right? And let me grab my. So I'm drawing this with a trackball mouse. So we'll see how good this comes out. I've done it a couple of times, but we'll see, right? The concept is the idea of like a torch or a flashlight, right? So hey, not too bad, right? If we look at the flashlight, um, we've got some component parts, right? Inside of it, we've got our batteries, right? And then we've also got a switch of some sort, right? And this switch is what connects our batteries um, to the light bulb, right? So the bulb is the final piece, right? And this is a very, very simple flashlight, right? And Um, when all of these parts are put together properly and they all work, we produce light. Um, a flashlight is a very, very simple piece of equipment to understand and maintain, right? The switch just connects the batteries to the bulb. The bulb, when it receives electricity, emits light. Very, very simple. The good thing, and the reason that I like to use a flashlight as an example, is all of these parts are testable, right? So if I hit the switch and the light doesn't turn on, well, the first thing I'm going to do is I'm going to check the light bulb, right? And I can check that light bulb fairly easily. I can maybe swap in a new light bulb or right, but my tests for the bulb are going to be very, very simple and easy for me to check, right? Maybe the first thing I check are my batteries, right? I pop out my batteries, throw them in a battery tester, and they're probably the most likely to fail, so maybe I should check them first. Um, when we throw the batteries into a battery tester, they're going to tell us, hey, these batteries work, right? The more difficult piece to test is going to be the switch, right? But again, the switch is not too bad to test because really we can rule out everything before we test the batteries, or before we test the switch, right? The light bulb and then the batteries um, are going to be, um, if I test them and then my flashlight doesn't work, then I know it's probably the switch, right? And maybe I can get out some electrical tools or something and test the switch to be sure. Um, the other thing to recognize is that a flashlight is very good at what it does. And because it's very good at what it does, it tends to be cheap, right? In the US, we could typically pick up a flashlight for around $5, and it's going to be a good flashlight. right? I mean, you can go way more expensive than that. There are way more expensive flashlights that include lenses and all these other things, but the typical flashlight, like a cheap flashlight's like $5. When we talk about, flashlights, what's the opposite extreme, right? Well, the opposite extreme is my smartphone, right? Um, if I purchase this to be a flashlight, well, if my flashlight doesn't turn on, maybe it's a software problem. I can't check the software. Maybe it's a battery problem. I can check the battery by checking the screen, but I can't replace the battery, right? My maybe it's the flash on my camera that emits the light. It's difficult for me to test that, right? If the batteries are on, I don't know if the software is causing problems. I don't know what's causing problems. So it it's a it's a way over engineered flashlight. And right, when we talk about a smartphone, smartphones are in the hundreds of dollars in the US, right? Um, it's not a good flashlight. It's way over engineered for what it's doing. Um, and because of that, it's not a good, it's not a good investment for me to use only as a flashlight. Beyond that, one of the pieces that makes it so difficult is that it's so tightly integrated, right? Um, Cell phones in the US are basically consumer products. When they stop working, they want you to throw them away, or send them to a recycler, right? They want you to get rid of your flashlight, your phone, and replace it with another expensive phone, right? And that's done on purpose. Um, so when we talk about maintainable, reusable software, we want to make our software more like the actual flashlight, right? Where we can test each individual battery. We can test the light bulb. We can test the switch, right? We can have confidence that things work. Our integration test is just testing the switch, right? Very, very simple tests. With with a phone, our tests become much more difficult, right? Maybe we have to unlock the screen. Maybe we have to do, who knows, right? Um, but we want our software to be long-term maintainable. This is what's going to help us in the current market where AI is producing a lot of code, right? Like agents are going through code bases and being like, hey, we need to change this, we need to change this. Or maybe they're making fixes themselves. Agents are generating code and things like that. So let's jump into the project. And am I serving the project? Let's see here. Um, Bring up my browser. Oh, I'm already in my browser. I always make this mistake. So nope, I don't have my serve going. Let's bring that up. Here we go. So npx nx serve. So this is the application that we're going to work on today. And this application was generated with AI. I'm not saying that to dunk on AI. I'm not saying that because, AI is horrible or whatever, or AI is amazing. I'm actually pretty impressed with what the AI was able to put together. Um, this was put together for a Teenage Mutant Ninja Turtles themed workshop. And so you can see that, we've got our top characters by high score, right? We've got Splinter, Leonardo, and Donatello are our top characters. We can click on the details and, down at the bottom, the details show up, with their skills and all of that. And we can close this and deselect it. And all in all, the AI, right? I vibe coded a fairly okay application, right? My users aren't going to be angry at this application. So let's go ahead and just take a look at our tests. And our tests are going to all pass. And these tests were all generated by, I used Junie from, um, I use Junie from JetBrains. I use WebStorm for a lot of my coding, and I'm not sure why it's not, why my stuff at the bottom isn't showing up. It might be the interaction with Zoom. I don't know. But let's take a look, right? We've got the service that we use to generate code, and we'll take a look at this service. The service just generates random code. Or it doesn't generate it's a static service that pretends to be an HTTP service. Um, so this code is going to be like your typical HTTP service. We aren't going to look at this too much because it's tested. We know it works. We're okay with that service, right? We do have the app component tests, and we've got some interesting tests here, right? This is the classic test that you see in almost any Angular project, right? It should create the application. That's like the lowest bar to cross. I argue that this test shouldn't exist. It should be an integration test. It should be a smoke test or something like that. But almost every Angular application has this test. It should render the title. Well, this is another horrible test because it doesn't really give us anything. Right, it should have the title testing structure workshop. The last two tests are the interesting tests that it should list all of the characters and should it have a list of top characters. So let's go take a look at our tests. So right off the bat, we know these tests are kind of we don't really want them. They're not great tests. We should get rid of them. So we're going to get rid of these tests right away. So the next test to look at are these tests that we're expecting something. And you know what? The set timeout is cheating. So let's go ahead and remove that set timeout, right? Because a lot of times we'll do this in tests and we'll get passing tests. But why did those tests pass? So let's run this again with our set timeout removed. And our tests still pass. Well, wait, why are my tests passing? Why are my all characters passing? What's going on here? Right? We're just compiling a test. Everything seems to be okay here. I don't want to delve too deeply into it. So let's pull up our test, our service. And in our service, let's just make our observable debounce, right? So we can pipe this, or not debounce, but let's delay it, right? So let's pipe it through the delay operator. And let's give it like a 200 millisecond delay. And do I have the delay operator up here? No. So it shouldn't know what delay is. There we go. We'll grab delay from RxJS. And now we've delayed getting our characters by 200 milliseconds. So let's go ahead and run our tests. And this one we should have a failing test now. If it's not, it could be because of the way that Angular uses a special test scheduler to run the tests. Yeah, we're still passing. This test should fail. I'm not sure why we're not failing. But here we shouldn't be getting in our test here. Um, and we could delay it using like an async await or things like that, but um, these tests in a real situation will fail if we don't add set timeout or fixture.detect changes or things like that. And part of the problem is let's take a look at the code itself. So let's take a look at the app component. And the app component is a fairly large template. Um, and in this template, we've got some issues. So we've got some styling going on inside of the badge, right? So we've got some logic inside of the badge that will need to be tested. We've got a click event that's calling show details. Um, we've also got inside of here, we've got an if there's a selected character, but we've also got right here, we've got some logic in our template. And logic in our template is something that we're always forced to test. We've got some more logic in our template here with the selected character skills. And so our tests aren't even good because we aren't checking that we're properly joining our skills. We aren't properly checking that, when we click the selected character button to unjoin, and that this is going to lead to some component testing that can be brittle. And, if we try to unit test the way a lot of people do, then it can lead to tests that don't do what they're supposed to be doing. So there's a lot of reasons why this template has some issues. So we need to fix up the template. The template is like our light bulb in our flashlight, right? It shows what's there. So really our template should have most of the logic removed, and it should just show it should only show what should be there. We shouldn't have logic like showing details. This is fine, right? Click events and things like that are fine. We need a way to wire up events. Logic like this, where we're setting the selected character to null, is going to cause problems. And now we're going to get into the actual component itself. And this is where the AI generated code really starts to fall apart. First of all, notice that we've got public properties for all of the data here. This is not good, and we can take this title out. It's not useful. We're not using it. So one of the first things I recommend doing, just to help our class, and the reason for this is let's say that I wanted to cheat this test, right? Um, let's say that the test was failing, and actually I can force this test to fail. I can come in and I can just say, hey, app.allCharacters equals an empty string, right? And now I've forced my test to fail. Oh, you know what? That set timeout was commented out and I didn't save it. That's probably why my test wasn't working. So let's go and run this again. And now that I've interacted directly with the all characters and I've set all characters to an empty string, we're going to see that I was able to interact with the component in a way that I shouldn't be able to. And notice now that I've got a failed test. My failed test is we should have a list of top characters. Okay, that's why it wasn't working before. So I hadn't saved it after the set timeout. And this is an issue, right? And people are working around this all the time, right? With we can add a fixture.detect changes here. and go back and run our tests. Um, and our tests will still fail in this case. Um, because we've got a race condition going on in our tests. And often the only way to fix those race conditions are with set timeout. No, the detect changes fixes it. Um, but we've still got an issue here. Um, and we can put our right, our detect changes. We shouldn't have to call detect changes all over the place in our tests, right? And you'll see all sorts of tricks like this, like us having to call fixture.detect changes, or us having to call set timeout, or things like that. But worse, I can influence this component in a way that a user can't. If I go look at the if I look at the application, there's no way for me as a user to be able to set all characters to empty, right? And you guys have seen tests like this before, where someone goes in and they interact with the component in a way that they shouldn't be able to. This increases the cost of ownership of this component. Um, the intermixed logic is also increasing the cost, but there are some things we can do to help improve this situation. One of the big things that I recommend is, hey, if there's no reason for something to be private, let's make it protected, right? Um, and there's another thing that I like to do. Here we've got a private TMNT service, right? Well, guess what? Um, well, first of all, notice now that I've broken my tests. I can no longer check the length of my top characters. I can no longer interact with top characters. And that's the important part. We've decreased the surface area of the API for our component, which means that tests like these, tests where I'm checking the length, doesn't actually check that the application works, right? All it does is it checks that that array has the proper length. But what if I do something else, right? So you know, let's do something else here. Um, I can mutate this array, and in mutating the array, I can cause changes that may not show up in the application. But I can make tests that work based on that, right? Um, and this is the problem. By making our application, our properties protected, immediately this test file becomes useless. And now we're going to have to use proper testing. To test applications, what we should do is we should use component tests. And we can use all sorts of different types of component tests. We could use Cypress component tests. We could use Playwright component tests. We could use material testing harness. We could use I don't know. There's a lot of different ones that we can use to do this, right? Um, but now we're forced to actually interact with the DOM. And so now we can check. And now we have to check that, hey, these rendered. So maybe we count the number of buttons, right? Because it's possible for the rendering not to work. Um, and it would be really, really easy. One thing that we could do, let's go back and let's just fix these for a second. But if we go to our app component and let's if I just bind this to an empty array, it's going to break, well, as character array. Does that work? I think this works in the newer versions, but Um, we could break this binding here in a couple of different ways so that it doesn't actually render, but our unit tests would still pass because we're checking the array. Um, so my argument is let's throw these tests away. They're not good. Um, we should be testing them in different ways. So now we're to a point um, where we don't have any tests, right? So we're actually worse off. We're a little bit better off because our services are, a little bit better. They can't be accessed from public interfaces, which means that we can't write improper tests against them. One other thing that I recommend doing is I recommend making our service read only and then using the TypeScript or JavaScript private service. Um, and the reason for that is by making it read only, um, our if we try to redefine it, we can't redefine it anymore. So there's a benefit there, right? So here, if I try to go this dot tmnt service equals new tmnt service. Notice that my compiler and stuff is going to stop me. So there's a benefit there. There's another benefit to using the private, truly class private stuff over just the private keyword from TypeScript. The private keyword from TypeScript doesn't truly make your code private. Using using the private symbol to make it private um, helps make the service actually private, and we can't access it outside of the class, right? The reason we make these ones protected is Angular recently added the ability for us to access protected code from the template, but it can't be accessed as the same as a public property. Um, so we're in a better place, but we've deleted our tests, we've caused issues. There's some other ugliness going on here. Notice that the way the AI wrote this is load characters calls get all characters on the service, subscribes to it, and then it sets the array in a subscribe. This is the reason that without like a set timeout or things like that, this code doesn't work. So let's fix this code. Um, and the way we're going to do it is we're going to add a store. Um, and my favorite store is the component store. Or not the component store, the signal store from NGRX. So let's add a new TypeScript file, and this file is going to be our app.component.store.ts. So there we go. So we're not gonna add this to Git because I'm gonna reset everything when we're done. But we're going to use another link that I shared earlier. We're going to copy this template that Michael Small put together. So we're just going to grab the raw template. We're going to grab all of it. We're going to copy it over. We're just going to drop that straight into we're going to drop that straight into our store. Oh, did I not? There we go. So here's our store. Michael has added all sorts of good stuff to it. So we've got a signal store. They're calling it a store. We're going to call this, because it's our app component, we're going to call it our app component store. And up here, we're also going to, instead of store state, we're going to rename this to be our app component state. So we've got a type and we've got a state. and it's a fairly simple state, but we don't actually want this state. What we want to do is we want to go to our app component and we want to move all of this stuff into our state. So let's go ahead and grab this. It's going to break our template, but we'll fix that here shortly. So our state is now going to be this. We no longer need the protected. Our all characters are this. And there's that. And we can delete that. So this is the shape of our state. The next thing we're going to do, and this is one thing where I'm a little bit different than the way Michael has it set up. I actually like to set up a factory function here. And so we need to add a couple of things to our factory function, right? So our all characters is going to be an empty array. Our top characters is also going to be an empty array. And finally, our selected character, we're just going to start with null. So there's our initial state. Because I changed our initial state over to a factory, we need to call the factory here, and that sets up our store. Props, we're not going to actually use props, so let's remove that. Computed, we don't need that. Methods, we will, and hooks, we will also use. So we've now set up our store with our initial state, and we can actually go back and we can make some changes to our template right away. So we need to get the store into our app component. To do that, we're going to go to our providers array. And we're going to provide our app component store. And so the reason we're going to provide it in this component is that this store is specifically written for this component. And we can think of it kind of as like the batteries for our store, right? This is only for the store. And I want to make sure that I get enough time to talk about testing. So the next thing we can do is we can create a read-only protected store, and we can inject our app component store. And in doing that, and I need to swap protected and read-only, so let's do that. So now we've got a store that we can use. So now we can clean up our template, right? So instead of all characters, now we can just do store.all characters. And that's fine. If selected character, we don't have that right now. Well, we do. We've got store.selected character, right? So if that exists, we're going to use another thing from Angular 20, the let. We're going to say, hey, the selected character equals store.selected character. But notice we're getting an issue here where the selected character could be null. So we have to go through and we have to add this operator because it could potentially be null. But notice we didn't have that problem before. And how do we get around that? Well, one way to get around it is just to move the let above this, and now we can say, hey, if selected character, right? And now we no longer need the conditional access operator, right? So but we've got a problem in our template. We've got two problems. First of all, our skills um, are still, uh, we've still got logic that we can't test in our skills, and now we're trying to um, set the selected character to null. How do we fix this, right? Well, the first thing we can do is we can go in here and we can say, hey, um, um, what did I do with skills? I forgot. We're going to cheat. All of the answers are here, and I'm rushing a little bit, so I want to make sure that we get this right. But if we look at our app component here, did we change our selected skills? No, we didn't. Okay, so never mind. What we could do for this to make it testable is we could create a pipe. Um, we're not going to do that today because I want to leave time for the Q&A at the end. Um, so this is an issue. Probably the best way to solve this issue is to just have a pipe um, that joins an array with a comma. And then we could just do selected characters, pipe, join, comma, whatever our pipe is. We can test that pipe. It's testable code, right? It's like a battery for our code or for our flashlight kind of, right? I skipped over that in, for time. But what we do need to take a look at is a selected character. There's this selected character right here. We can't reset that. So let's go into our store. Um, and we may need some computeds here, but we need a method, right? And we need a deselect character, which is a function that will return void. And we also need a select character that's going to take a character to select and return that, right? With signal store, it's really, really easy to make these changes. We just call patch state. And then we're going to patch the state. And we can just say, well, first of all, we want to pull in the state. Oh, come on. So we need to tell it, hey, we're going to patch the store. And the nice thing about patch state from signal store is that we can just provide the parts of the state that we want to change. So our selected character, we can just set it to null. The nice thing about this is if we name this properly and we call it selected character, then it's really, really easy to select a character because now we just call patch state, we give it the store, and we say, hey, we just want the selected character. And that's going to patch the state with our selected character, and we're good. This is very, very testable. So here we need to fix this issue with the selected character equals null. What I like to do is I just like to say, handle deselect character. And then down here, we can add a protected handle deselect character. And this is just going to call our this dot store deselect character, right? It's just a wrapper around that. The reason I like to create handlers is you might want to do some processing on the data that comes in, right? So we fixed that one. The show details, again, it's trying to use selected characters. What we can do is we can just say, hey, this dot store dot select character. Again, we've wrapped it, right? And the final thing we can do is we can say, hey, um, you know, all characters, we need to load the service, right? Um, really, that's the only thing we need to do. So we need a couple of things to do that. Um, we go into our app component store, right? And we can add a get all characters. It's going to be a void. But we're going to make this private to the signal store. The other thing we're going to do is we're also going to load or get top characters. And this is also going to be private. But I made a mistake here. What we actually want to do is we want to use an RX method. Yeah, we do. Do we want to do that? If we do that, we can patch. Yeah, we're going to do that. So we're going to say this is an RX method. And the nice thing about an RX method is it allows us to get RxJS into our code. So we can immediately call pipe like we're using an RxJS operator, right? And then we can immediately switch map. And in our switch map, we need to be able to call the service. So we can say, hey, const, and our TMNT service equals inject TMNT service. Boom. So now we've got our TMNT service in our methods. And because our signal store runs in an injection context, this is going to run in an injection context. So now we can switch map over to TMNT service dot get all characters, right? So let's bring in switch map. Yeah, come on. There we go. It's not an equals, it's a colon. So now we switch mapped over to the TMNT service. The other thing we want to do is there's a tap response that RX or NGRX adds. And maybe I added it. Did I add it? I haven't added it. NGRX adds a tap response that forces you to handle success and errors. We're instead just going to tap. Come on. And here we can just say, hey, our characters. And now we can say, is it going to allow me to import characters now? Import from RxJS, tap characters. And so now we can just say, hey, patch state, and our store, and our all characters is characters. We can actually rename this to be all characters, right? And in that way, there we go. I need a comma. So there we go. Now we've got all of our characters in place. And with getting the top characters, it's just basically the same thing. We just go to an RX method. And our Rx method's going straight to a pipe. And then our pipe is going to immediately switch map to our get top characters. And we're going to ask for the top 3 characters. And then we're also going to tap with um, top characters. And we are going to, again, patch our state, our store with our top characters. And I need my comma. So there we go. So now we've got that. So the last thing we need to do is in our on init hook for our store, we can just say, hey, store.get all characters and store.get top characters. Um, and our Rx method is an unknown. Here we can just say that this is a void. I believe this works. And a void. And that should work down below. Yep. So by setting void on our Rx method, we're basically telling it that it won't have any parameters, which allows us to pipe straight in. The nice thing about Rx methods is you can give an observable to an Rx method. You can give a signal to an Rx method. You can give all sorts of stuff. But the really cool thing about what we've done is we've interfaced RxJS with signals, and we haven't had to subscribe anywhere. The signal store is taking care of all of that for us. So now we can go back to our app. And guess what? We don't need this. So all of this code goes away. Our ng on init code goes away. We don't need the service anymore. Our show details and handle details are here. But we've taken this component and changed it into very, very little code. And by making it, oh, I need to also make sure that we've got store.top characters here. So the first thing we've done is we've basically taken all of that mixed code that was expensive to test, right? And we didn't even have proper tests for it. We've taken all of that code, we've made it into one line of injected code and a few lines of wrappers, right? We could put this stuff straight into the template if we wanted. This is a personal preference of mine. You don't have to. The other thing we can do is go protected. And now there's no public interface to this class. The benefit to this is now you have to use E2E testing. Now you have to use component testing. There, right? You have to properly test this component. Does it work, right? Is the next thing to take a look at. So let's see if we can serve it, right? npx nx test or serve testing workshop. And I'm just checking the time. We've got about 5 minutes. We're going to copy the tests over and talk about them. Because I want to make sure that we leave plenty of time for the Q&A portion. But there we go. We don't have any issues with compiling. Once it refreshes, we can see our details down here. And when we close, it closes. We can set our details here. So we've fixed our code. We've separated out our code. But you're like, this is a whole bunch of extra work. What's the benefit, right? So let's go take a look at what is the actual benefit. Well, first of all, our tests are going to run a lot faster because we aren't having to load component tests in, right? And we can run component tests through component testing tools that are optimized to run component tests. If you still want to keep your component tests in with your unit tests, now you're going to have to use test harnesses like from Material or something like that. So our tests all run, but we aren't testing this code. And, why do we care? We're going to cheat and we're just going to copy these tests over. Um, and then we'll take a look at the tests, right? Well, let's take a look at the tests first. Oh, we've got the empty TMNT character. Um, we need to do one other thing. So we need to bring that in. Um, there was one piece that we didn't do was the empty character. The empty character is a way to avoid the null checks that we were doing. We did it by using a let variable. Um, so let's grab all of these and let's rename it to app component store. Um, and then here we want to take a look at this. How come I didn't grab that? App component store. And then this one, um, so here it's saying empty character. We're just going to set it equal to null. Um, if you want to take a look at how the empty character works, you could take a look at the um, at the testable code. That's going to help you with that. But the testing structure workshop is the stuff that we went through. The testable code is the solution that we're working through ourselves. So if you guys don't remember stuff or you just want to go in and investigate some stuff some more, um, you can do that. So what we do is we set up two observables that are just subjects. We then say, hey, when you provide the TMNT service, just use this value. Get all characters is going to use this observable. Get top characters is going to use this observable, right? Um, so it should create the store. Great. This is the generic test. I don't know that there's a lot of value in this because all the other ones create the store too, right? Um, so I don't know why I left that in. I think it was just an example of what people do, right? Did I break something with that? So the next thing is that it should load all the characters. So what we can do is we can just set up a test the normal way, right? We can inject the store. We can set up a couple of tests and then we can say, hey, on that observable from the store, emit characters, and then it's going to expect the characters to equal the characters. Notice that I'm not having to do any fixture dot wait. I'm not having to do any timeouts or anything like that because Signal Store is handling it properly for us. Same thing with the top characters. It's almost the exact same test. Um, and then it should select a character. Notice we weren't testing that before, but now we are. And then finally, it should deselect a character. We weren't testing that before, but now we are in our store. We do need to write some component tests to make sure that the buttons are properly wired up, right? Um, because we want to make sure that the UI interacts with our stuff, but we're forced to do that. We can't interact with the store outside of component tests. So our stuff becomes much more testable, much more safe for people to maintain. And if we run our tests again, it's going to set everything up. NX, we're using NX for our testing. Um, NX is probably, well, no, it is my favorite tool for Angular. Everything I do, I run through NX. But you can see our app component store was all properly tested. The tests are really, really easy to follow. Um, and That's not our tests. These are our tests, right? Our tests are very, very easy to follow, and they tell us what the store should be doing. Um, so that is a bunch of stuff boiled down into 1 hour, right? Really, really condensed, really, really fast. If you guys have questions, reach out to me on Twitter, reach out to me on LinkedIn, reach out to me. Come attend the streams. I stream on YouTube, um, Twitter, X, and I said YouTube, X, and Twitch. So if you guys want to dig in deeper to this stuff and ask more questions, um, come join us. I stream every Sunday at 10 a.m. Mountain Time. So about an hour later than today. Um, but yeah, thank you so much for having me. I really, really enjoyed it. Looking forward to the questions.
Okay. If you have a time, we have 6 questions.
Awesome.
Our chat on YouTube. So I will start. The first question is, what are some of the most common mistake developers make that lead to unstable code from a Humayun user? So
Yeah. Oh, that's a good question. The most common errors that I see were actually some of the errors that we saw before, right? One of the biggest errors that you can make, and I want to preface this by all of my advice is very much when you talk to an architect, everything is like it depends, right? So my advice today is when you get into enterprise level code or code where you're working on it with a team, that's where this matters. If you're learning, if you're working on something for yourself, you're optimizing for things that matter to you, and that's okay, right? So I'm not saying that every time it should be this way, but what I am saying is once you start working with teams, this will start causing issues. One of the biggest issues I see is mixing state with your components. And the reason that that's a big issue is if we go back and take a look at if we go back and take a look at our Excalibur, right? We want something that is a flashlight, right? Um, as soon as I start integrating any of this stuff into the flashlight, I can no longer test that without testing the entire flashlight, right? So if I seal the batteries into the flashlight, there's no way for me to know that the batteries work. Right? Like I can't be certain that the switch or the light bulb doesn't work without tearing apart the whole flashlight, potentially voiding my warranty, right? Doing things that I shouldn't have to do. So as soon as I make my state modular, and we can think about our state kind of like the batteries, right? And our template kind of like the bulb. As soon as we start mixing logic into templates, as soon as we start mixing state into the bulb, right? Like if I integrated the batteries into the light bulb, that makes my light bulb way more expensive. It makes my light bulb way more difficult to test. Maybe it was a cool idea, and maybe we're optimizing for something like, maybe integrating the batteries into the light bulb. Maybe I'm optimizing for the size of my flashlight, or who knows what, right? There are reasons that you might do that, and that's why they're like my advice is always it depends. Um, but in general, once you start integrating state into your template, it's like integrating your batteries into your light bulb, right? Um, it, with an example like this, we can quickly see, oh yeah, there's a lot of problems that could come up because of that. Um, because once we integrate the batteries into the light bulb, then the switch has to do something way more than just connect the power to the bulb, and it becomes way more difficult, right? Um, so that is a very common mistake I see people making. Other common mistakes are over engineering. It, it's it's like the eternal curse um, of developers in general. Um, that most of us tend to be perfectionists, right? Most of us, when you give us a problem, our brain just starts solving that problem. Um, and that leads to a lot of cases where we over engineer, right? Or we get stuck in the swamp of perfection, I like to call it, right? If we wade a little bit into a swamp, it's easy for us to get out. But as soon as we've waded into a swamp, like it's up to our chest, right? Now for us to get out, it's difficult. Any direction we go is going to be difficult. And it's the same with us as developers. Over engineering a solution. We need to be confident enough to say this solution is good enough for what we need. It's testable, it's maintainable, it's easy to understand, and let it go, right? And I struggle with this one a lot. I want my stuff to be perfect, right? Down to the exact indentation and all of that stuff. But sometimes it's just good to let it go.
Okay, next question is from a coder. Are there specific Angular features like dependency injection or server sets that help simplify testing when used properly?
Absolutely. There, dependency injection is a powerful tool. And one of my favorite tools, injection tokens through dependency injection, right? Um, these are more advanced topics, and most solutions don't need injection tokens. Most solutions um, don't need the more advanced stuff. But dependency injection is very, very powerful, right? We're using dependency injection in our test store here, right? We Because we injected the TMNT service, we're able to replace it in our providers array here. And this is the power of the Angular dependency injection. This provide is really a token. Um, and we can provide anything for this token that matches the shape that we want. And it's a powerful tool to even use in your components themselves. Um, you could you could set up powerful state machines using providers and tokens, where in certain instances you can use a factory here. So in certain instances, you could provide logic that provides an edit service or an add service, or so you could have different logic that fires when you add or edit an item, right? Um, there's a lot of power in the tooling that Angular provides. There are other powerful tools. So the test bed, in the past, test bed was slow. As of Angular 15, test bed is as fast as any tool out there. They took a lot of the optimizations that tools oh, like Angular testing framework, and man, it's been so long since I used it. There was another testing framework that actually optimized the test bed. Angular took those ideas and optimized their own test bed. Test bed is very, very powerful. And so now you can use things like testbed.inject, testbed, right? And you can override providers and you can do all sorts of cool stuff. One place where the test bed is weak is if you want to override providers that are provided at the component level. So when we look at like this app component here, and where we're providing the app component store, um, if we go back and we want to write tests against this and we want to inject our own app component store, you actually have to remove the component store from the provider's array and then add your own. So it's a little bit clunky, but I think they're working on that. So I think that that will be fixed in the future. But yeah, the test bed, dependency injection, um, taking advantage of injection tokens can can really those are good ones to use from the Angular framework itself that you can use in every project. Um, yeah,
Okay, I will read all four questions because the meaning is, I think it's the same. Okay, from Asylum by how can a team make a testing a natural part of a development process rather than an afterthought? The second
mm,
question is, what role does code review play in enforcing testable architect?
hmm
And from a macOS user, its question is, why is a code structure such as a critical factor in determining the easy or difficult of testing? And the
yeah.
last question is, how does tightly coupled code impact unit and integration testing?
Oh wow, those are good questions. So the first two I'm going to address together. Because they talk more about like cultural right cultural solutions. Um, and this is an important part of any development team. Um, and I think it's one of the areas where we as engineers and developers fail a lot. We tend to look for technical solutions to problems that are often human issues. Um, um, what do I mean by that, right? One of the most common things you'll see is people will go into their unit test files and they'll say you have to get like 100% coverage or you have to get 80% coverage, right? And so then they'll set their tools to look for those coverage thresholds. Um, and then you'll get you'll get other technical solutions to these problems. Um, I think you need a minimal test threshold. Um, that test threshold, I often say, is like 50% or less. And the reason I say that is once you set test coverage to 100% test coverage, you get people writing tests solely to cover code and not to test cases, right? And those tests are often not good. Those tests will often be, set this property to, value XYZ. And then the next line is expect this property to be XYZ, right? That test is horrible. You're testing the framework at that point. It's not a good test. And so, quite often when you go about testing solutions from a technical standpoint, um, you're going to fail. You're going to wind up with bad tests, and your tests aren't going to catch problems. The other side of that coin, right, is we can't go purely cultural. It has to be, and this is something that I talk about quite a bit. Like everything in engineering isn't like a one or a zero, right? We tend to think that way because computers are binary, but there's often a scale, right? And if we look at this as our cultural solution and we look at this as our technical solution, if we go all the way over here, we're going to wind up with horrible tests. If we go all the way over here, we're going to wind up with people that are going to take advantage of the culture and potentially not write tests, right? We need to be somewhere in between the two extremes. Where that is dependent on your team. But what we need to think about as engineers is we need to implement a minimal amount of technical that's going to encourage people to do things, but then we need to encourage the culture. And the way you encourage culture is you reward what you want, right? If people are writing good tests, make sure they're being rewarded for those tests. If people are writing good tests, encourage them to show others how they're coming up with good tests, right? Um, the code review process that somebody mentioned is a mixture of technical and cultural, right? Um, and I'm sure you guys have worked at organizations where somebody throws up a code review, 20 minutes before the end of the sprint, and everybody just kind of, yep, rubber stamp, we're good. This goes in. That's not a good code review process. A good code review process is going to be looking at certain things. When I encourage people to start building a good culture of testing, the first place that I like to encourage people to go is when you review somebody's code, look for their tests. Go through and read their tests. So before you even look at the code that they wrote, look at the tests they wrote for that code. And then understand what those tests are trying to do, and then go review their code. If their code does more than what those tests do, then you know that the tests aren't good and the code isn't good, and you can kick it back and you can say, hey, your tests don't match what the code does, right? And now you're encouraging people to think about their tests. The other side, right? If the code does more than what the tests do, then you can be like, hey, you didn't test this case, right? Or you didn't do that. And so now you've got a good mixture of technical and code review. You definitely need the code reviews, the pull requests, right? Those are an integral part. And a good way to build a good testing culture is to train your reviewers to look at tests first and then review code. Um, and always look for tests and things like that. But code coverage, yes, you need it. I look at code coverage as being on the technical side. Cultural, I look at that as training and rewarding people who are writing good code. Um, so that was the first two. There were two other questions, and I wanted to address them separately. What was the third question again?
Question is, why is a code structure such as a
Mm.
critical factor in determining the easy or difficult of testing?
And this is a question like this is a softball question, like teed up perfectly for me. Whoever asked this question, thank you so much. Good question, right? Why is it important? Um, we kind of explored that here, but it also goes back to this drawing, right? If I build an integrated flashlight that's over-engineered like my smartphone, I've built a poor flashlight, right? Obviously, a smartphone does more than just be a flashlight. And so, if that's the use case, then maybe building a smartphone is what we need. I'm not saying don't build smartphones. What I am saying is when you need only need a flashlight, and you build a smartphone, that's a problem. When we look at a flashlight, how we structure the flashlight is important, right? If we put the bulb at the back of the flashlight and the battery's in front of it, well, the only light that's going to come out is the light that makes it around the batteries. It's a poor flashlight. It's the same thing with our code, um, right? When we start doing things with our code, like integrating batteries into the bulb, or if we start moving the bulb into weird places, um, that structure is going to work against us, right? And suddenly, if we move the bulb to the back of the flashlight in this example, right, and our batteries are at the front, suddenly our users are going to start complaining, well, your flashlight isn't very bright. Your flashlight has this big dark spot in the middle of it, right? I have to aim your flashlight weird. And your users start asking for weird stuff like, hey, can we make it easier for us to hold the flashlight at a weird angle, right? And so then we start getting weird solutions that we're testing where we add, a weird handle so they can hold it at a weird angle so that the light that leaks out, right? No, that's not the right solution. If we put the bulb at the front and the batteries at the back, like most flashlights, we wouldn't get those user requests. It's the same with our code and testing, right? Um, Early on, we looked at the tests that we've completely removed from our application at this point. Um, those tests weren't good because one, they failed as soon as we removed a set timeout or things like that, right? They didn't catch weird edge cases. There's some edge cases in that code. I encourage you guys to go check it out and um, dig into that code. There's some weird edge cases and some weird things that you'll encounter as you test it. The fixed code fixes all of that. And it comes down to the structure of the code, right? Our component only does what a component should do. It only displays information to the user and collects user events through button clicks, right? Our store handles the state. It handles state transitions, right? So when we deselect a character, we're transitioning from a state where we have a selected character to where we don't have a selected character. When we select a character, we transition to that state, right? Get all characters transitions from a state where we don't have characters to a state where we have characters. All of this stuff is important because we can test this, right? And we showed that we can test it. Um, because our tests are here, our tests are simple and they test the use cases that our store has, right? We test that we can select a character. We can test that we can deselect a character. We test that we can get all the characters. We test that we can load the top characters. And these are all important tests to have. And these tests are easy to follow and understand. So that's where the structure comes down. And then I saved the fourth question for last on purpose. Um, what was the
Yeah,
fourth question?
uh, it is how does a tightly coupled code impact unit
Oh,
and integration testing?
yeah, yeah. Um, that's a very good question, right? And um, the the point of coupling code um, is sometimes it's important for code to go together, right? And in this case, we could even argue that the app component and the app store are slightly coupled. The reason that they're coupled is that the app component relies on what's in the store, right? Like our template has stuff in it that's coupled to the component store, right? Our component store is slightly coupled to our service. Um, we inject the service into the store, and we rely on what's returned from that service to um, to set the characters and to set the top characters and things like that. There's a certain degree of coupling in all code. It's once and that coupling is important because that's what gives us the types. That's what allows us to rely on contracts, right? Like contracts are a degree of coupling. Um, we've got some indirection going on through the dependency injection. And this is what turns our coupling from something strong into something um, that's easier to maintain. We could make this much more tightly coupled, right? By coming in here, and if I removed the providers array, which basically removes the dependency injection, right? And instead of doing that, I do a new app component store. Um, Suddenly it becomes way more difficult for me to control things. And we can even see this. We can even see this in our store itself. If I changed this inject from this to be a new TMNT service, I've gone from loosely coupled to a tightly coupled situation. And this becomes an issue because now if I go run my unit tests in this case, um, my tests are going to fail. And My test should have failed. Um, TMNT service. I'm actually a little bit confused here because this should have called the TMNT service. And when I call get all, I should have gotten 5 characters, right? And then my top characters, um, I'm not sure why this didn't fail, but it doesn't break what we're saying, right? Um, by me saying um, by me saying new TMNT service, I am tied to this TMNT service. For me to change this in the code is incredibly difficult, right? Uh, as soon as I use dependency injection of some sort, um, this is a token that gets me TMNT service, right? When I look at this token in my tests, I've set up the token to return a certain value, right? This token returns just a simplified version of the class that doesn't have all the logic and maybe doesn't make HTTP calls. And this is the problem with tightly coupling. Once you tightly couple, it's almost impossible for this to happen, right? We can't replace a service with something that we want to control, and we can't emit specific values on the service, right? By me making the service this way, get all characters, I can control what get all characters emits. I can control what top characters emits. Um, and that's the problem with tightly coupling. And even without dependency injection, there's a lot of things that you can do. You can pass things into functions and things like that. Breaking tight coupling like that is always going to make your code better. Um, so yeah.
Okay, thank you so much, Jason, for that insightful and practical decision on a structure code to avoid the shell socket testing. Your guidance on writing test friendly architecture and avoiding the common pitfalls of a tightly coupled code will definitely resonate with developers working with the real world Angular replication. It always inspiring to learn from someone who not only master the framework but also give us back so much to the community. To everyone who joined us today, thank you for being part of this meetup. We hope you are walking away with the new ideas and actionable techniques to improve your testing strategy and the code base. Let's continue learning, building, and growing together as a community. See you at the next time. Enjoy as a season. So.